Welcome to another tutorial for the TI-30XPlus MathPrint calculator. In this session, we take a journey into the stratosphere with linear regression. Imagine you release a helium balloon close to the surface of the Earth. Within seconds of release, your balloon is travelling upwards at a speed of almost 5 meters per second. What will happen to its speed as it travels towards the stratosphere? Will it slow down? Perhaps as the pressure difference between the balloon and the atmosphere gets smaller, the upthrust will decrease. Or will it speed up? Perhaps as the air becomes less dense, there will be less resistance to the balloon and it will accelerate upwards. Will it travel at a constant speed? Perhaps a combination of A and B will balance perfectly and the balloon will travel upwards at a constant speed. On a fine day in France back in 2013, Maxime Douay launched a weather balloon with a collection of cameras and onboard instruments that measured time, altitude, pressure and temperature. We can use Maxime's video to help us answer our question and learn a little bit about linear regression along the journey. I'll begin by clearing all the lists on the calculator to ensure we're ready for launch. At the time of release, the balloon was 127 meters above sea level. So this gives us our first point, 0, 127. "20 seconds later, the balloon reaches an altitude of 223 meters. Our second point. At the 40-second mark, it reaches 321 meters, our third point. For the purposes of this video, we'll just use 4 points. And at the 60-second mark, the balloon is now 426 meters. So, our final point, 60, 426. We can plot these points on a graph for a visual inspection. The points appear to be in a straight line, so we can use some linear regression to determine an appropriate equation. On the calculator, press Second, Data to access the Statistics and Regression menu. Navigate down and select Linear Regression, option 4. Time is our independent data and is located in list 1. Altitude is the dependent data and is located in list 2. We're not dealing with frequency data, so I'll select 1. And finally, I'll store the equation in f of x. Navigate down to Calculate, and now we have our equation, 4.975x plus 125. Notice that the r squared value is very close to 1. So, our first 4 points are almost perfectly linear. We can use our equation to predict where the balloon will be in 2 minutes. You can either quit or press clear to exit the stats results. To predict the balloon's height or location at the 2-minute mark, I can recall the equation by pressing the table button. Select f of x and enter 120. Our linear regression equation predicts the height of the weather balloon at the 2-minute mark as 722 meters. I wonder how accurate our prediction is. How long before the balloon disappears into the clouds some 2 kilometers above sea level? For all of these answers and more, download the activity from the Texas Instruments Australia website and watch the YouTube video by Maxime. A link is provided in the description below and also on the worksheet. That's all for this tutorial. Thanks for watching.